Watch this, you'll have Chemistry Paper 2's chromatography practical on lock. Chromatography is used to separate a mixture of soluble substances. Remember, fundamentally, those are substances that can dissolve. It involves two phases, a stationary phase and a mobile phase. With your setup like this, your stationary phase is the chromatography paper. The mobile phase is the liquid that moves through that stationary phase, our paper. So in chromatography, that's your solvent. So how does it work? Well, the setup in this experiment is very important and it's commonly examined. First, we draw a line on some chromatography paper. It's very important that line is drawn with a pencil. That's because if you used an ink, it's likely to dissolve into your solvent and move with that substance you're trying to separate. Great, so on your pencil line, you now place a spot of the substance you're trying to separate. Then, into a beaker of an appropriate solvent, we then place that chromatography paper so the bottom part of it is inside the solvent. Really important here that that pencil line remains above the solvent. If not, your substance would just dissolve straight into the solvent. What chromatography relies on is the solvent moving gradually up the paper. When it reaches our substance, that will dissolve into that solvent, being carried with the solvent as it travels up the paper, and in doing so, separating the different components. They become separated because different substances will travel different distances up that chromatography paper. So you end up with something that looks a bit like this. Now this is great because if we had two sets of chromatography results, we could easily compare the substances that these different things contain. Things at the same level are the same substance. So comparing the results of two different chromatography experiments, you can easily see if there's a common substance between these different mixtures. We can also calculate something called an RF value. So you measure the distance your substance moved, then also measure the distance your solvent moved, and then write it as a fraction, substance distance divided by solvent distance. That will give you your RF value. Now, since it's the solvent moving that carries the substance with it, it's absolutely impossible that the substance can move further than the solvent. Therefore impossible that your top number of your fraction can be bigger than the bottom number, and therefore impossible for you to have an RF value that is ever greater than 1, since that fundamentally would suggest your substance managed to go further than the solvent, which will never happen. And those RF values we calculate in that way can be useful in helping us identify different substances, since like we said earlier, substances that are the same will have the same RF value. That's everything you need to know. I hope that helped. Let me know in the comments if it did. Save this so you can watch it before your chemistry paper 2, and best of luck in your exam.